to the next episode of our series looking at the different manufacturing products that Autodesk have available to us. Today we're going to be back inside of Inventor and looking at the assembly environment and a few of the nice features that we've got available to us inside of Inventor's assemblies. As you can see, again, straight from the onset, we're right back in the home screen where we started off last time. And for this one, we're essentially just going to go and use a different file type, and this is the assembly file type. So this is the IAM file format. And we're essentially just going to start bringing in, and I just want to just show you how easy it is to create assemblies using existing parts. Last time we looked at creating parts, using all of the geometry inside of parts to create actual bodies, and we're going to now look at how we can bring those bodies into assemblies and make the most use out of these individual parts to bring together a great assembly. And as I said, the assembly is just going to be an assembly file, and it's just we can open it here from the home screen, or using we can create a new file, and inside of that we've got standard assemblies that we can create, and this will bring up a assembly template. I've got a few set up or pre-configured already, so I'm just going to start off with some of those, but essentially I'll just show you how easy it is to get an assembly started. So just by selecting assembly in here, what it will do is it'll look at the template library that we have available to us, and any criteria that we set up as our base template will essentially be selected from this list. So it'll automatically, as soon as I click on that, open up a assembly template. All that we need to do from here essentially is to start dragging and dropping or placing down individual parts, whether they be just part files, or we could also embed sub-assemblies. So we can embed other assembly files into our assembly to create sub-assemblies. And to do so, it's just a case of up here in the top left, under the Assemble tab, we've got our components. It's just a case of essentially placing down a component. So as soon as I select place from the list over here, it'll then go back into my database, my local storage, my local folder, and essentially look for files that are inside there that are eligible for placing in. You can see it's picking up all files, but it will essentially be able to pick up any of these files, but the most important ones, or the most common ones at least, will be IPTs and IAMs, the Inventor assemblies and Inventor part files. It's then a case of just clicking and placing any of these down. Say for example I wanted to bring this leg in, I'll just open here and place it down. I can click to place that down, and I can place down multiple instances of this anywhere inside of my assembly. And once we've got them placed in, it's then a case of adding either constraints or joints to ensure that they remain within relationships to each other. So obviously when we're placing down in the real world, we're placing down legs on, or a countertop on legs. We know that there's going to be a certain relationship between those two, and inside of the assembly environment, it's much the same process really. We then need to establish what the relationship between certain components and certain parts will be. But as we start off, we need to essentially set down at least one item that's grounded. Otherwise, all of your items will be able to move freely in the open space. And as you can see here, I'm just clicking and dragging to move these individual components around. What we need to do to ensure that at least one of these components stays exactly where it is we can actually ground a component. So the other items, the other assemblies that I'll show you just now have these in, but essentially all that we need to do for that is we can pick the item that we want, the component, the part that we want to, and we can essentially ground it to make sure that it doesn't move around. And we can do that inside of the model browser. As you can see, very similar again to the part files that we had last time. We've got this model browser here. We've got one as well for the assembly environment, where this one lists individual parts. So I can right click on any one of these and select grounded from the list, and you can see that then adds a little pin to the item in the browser. and that leg now won't be able to move around. I'm clicking and dragging on it and it won't move around. However, all of the other ones move around. So you can see we can very easily place one component down, make sure that it's grounded, and then we can start building on top of that, whether we want to add constraints or joints. So I'm just going to jump over to one of the other ones that I've got pre-configured just for the sake of time, just for the sake of this demonstration. And that's this table over here. So as you can see with this one, I've got this tabletop, which is just this flat sheet of wood. And then I've got a side sub-assembly. So the only reason it's a sub-assembly is because I've added these dowels in where the holes will then attach. So you can see again, we've got a sub-assembly inside of this assembly. So that if I had to open this up separately, you'd see it's just a normal assembly with a single part and 4 dowels coming into the side, just to make sure that we've got this detailed as much as we can. If I have a look here at the assemble tab, again, we've got those same options. We've got the place. We've also got the ability to create more on that a little later on. But essentially, we've got our 2 parts, or our part and our sub-assembly in the list. All I now need to do, if I wanted to, is come in and place down from my local folder structure. So if I select place in the list over here, just want to make sure I'm in the right one. Looks like I am, so that's perfect. And I want to place down another side with dowel. So I'm going to select this one and select open, and you can see just by doing a single click, I double clicked on there by mistake and it's placed it down automatically, but all I need to do is place down with a single click and it'll then place that item down in there. To remove this from selection, I can just hit escape and it's done. I can then come in and I want to start adding some constraints to this. So constraints will ensure that there is a relationship between planes or axes essentially. So inside of our assemble tab, again, where all of our assembly options will be, we've got a relationships panel where we've got the ability to constrain our items together. And what that'll essentially do is it'll lock the movement in particular directions. So if I select constrain over here, you can see we've got the ability to add some relationships between components. So if I wanted to add a relationship now between this tabletop over here and this side, the side with dowel, I can come in and choose different planes on the 2 geometry to make sure that those 2 planes or faces then have a relationship, and we can control and manage the relationship between those. So the first one, and the one we're most commonly going to use today, is the mate constraint, and that can either be flush, flush is on the right, and a mate constraint. And essentially what that means is the 2 planes, they'll either be facing each other, and that's a mate constraint, or they'll be facing the exact same direction, whether they be attached or side by side. That's a flush constraint. So both planes are facing the same direction. And the way we know which direction they're facing is when we initially select the item. So as you can see, I'm hovering over the top face of my tabletop over here, and I'm given a little arrow pointing out from that face, essentially showing me that this face is pointing in that direction. So if I do a single click on that, it'll then add this as my first face for the constraint. And then if I move my camera around, just because I want to attach that face to the bottom face of my side panel. So you can see again, I've got the arrow pointing out from that. So I know that those 2 arrows need to point towards each other when the relationship is made. So if I do a single click on there, you get a little sound effect to say that the relationship has been created. And you can see that the alignment is correct at the moment. Those 2 faces are now attached to each other. And that's using a mate constraint. I could come in here at any point and add an offset to that. So essentially that means that those 2 planes are aligned. At the moment there's no offset, so they're making contact with each other, but you could set an offset if you wanted to. Say, for example, if you wanted a 20mm offset, you can see if I view this from the side, there's now a 20mm gap between those 2 faces. In this case, I don't want one, so I'm going to put it at 0. Once you're happy with your constraint, you can then hit apply. And then you most likely want to add more constraints to that, because at the moment, if I just hit escape on here, you can see this side can now move back and forth along that face. It can't move up or down. If I go to the side view again, hello, thank you. if I try and move it up, you can see it can't move up and away from that surface. It's locked on that plane, but it can move side to side. So I can move it all the way off to that side and all the way off to that side. And that's because it's only locked on that plane, and that plane is pretty much infinite. So you can go as far away from that as you want to, really, but those two will always remain in contact with each other, the planes themselves. So they'll always be aligned to each other, essentially. So if you want to lock this into further positioning, obviously in this case we want to make sure that it's locked to the side and locked to the front as well in its positioning. We can then add further constraints to this. So I'm going to add another constraint to the side over here. And this time, instead of it being a mate constraint, which would mean that those two faces are aligned towards each other, I want this to be a flush constraint, which would mean that these two are aligned in the same direction. So the plane is then facing in the exact same direction. And you can see by doing that, if I go to the front view again, those two faces are now aligned. So if I hit apply again, that'll then apply that condition to it. And the only thing that's really left for movement now, it's locked in its position in the X, and it's locked in the Y. All that's left is the Z according to the orientation down here, the coordinate system down at the bottom. So all that's left is for me to lock the direction in the Z. So if I select this option, that face, and you'll see now that those two are locked. If I hit apply, that then allows me to move that. So now with this top face over here locked in place, using the ground that I showed you in the previous example, you can see I've got the little pin showing that that tabletop is grounded. That means that now if I had to try and move any of these other two, they're not going to move around anymore. Awesome. So I'm just going to delete this one quickly. You can remove ones that you've placed down before. And then the other thing I want to just show you quickly is if we wanted to place legs. I'm not going to completely assemble this one. I just want to show you how we can add those constraints in. One of the other ones we've got is the ability to, some of the other constraints we've got, which I'll just show you now with the other tabletop that I'll apply to the top of this one. So if I had to come in and place another one quickly, I'm just going to use the same, no, that's the assembly, tabletop, that's the one, and place it down just like that. So you can see with this one, trying to remember if there are any holes for the dowels in here quickly. Yeah, they are, perfect. So you can see I've made little holes there for the dowels just to show how we can use other constraints to apply that. So if you didn't just have a flat surface, you've got a cylinder that you want to insert into a tube or something, you can use constraints for that as well. So again, if I come into the constraints option over here, you'll see that we've also got the ability to use an insert constraint. We've also got the ability to use an angle constraint, which will change the angle or it'll drive the angle between planes. So much like the mate constraint is at 0 degrees, they flat up against each other. We've also got an angle constraint, which will adjust the angle between those. We've got a tangent constraint, which is then between a circular surface, so a cylinder, and a flat surface, to make sure that those two are always tangential to each other. And then we've got an insert constraint as well. And I'll just show you the insert constraint for this one as well quickly. So with that in mind, you can see I can use a circular reference there for the cylinder, the extrusion that I've created in this hole. And you can see it picks up a central axis. And what that'll do is it'll then align that one to the dowel that I have on the other side. So I'm just going to pick this one over here. And just bear in mind the direction of the arrow. So it's always important just to bear in mind the direction of the arrow. It's pointing up out of the hole. I then want to select this one, and you can see this one's also pointing up out of the dowel. If I select that one now, notice how it's automatically picked that up for me. So I haven't really had to do anything. You can see we've got opposed, which means that the two arrows will go opposed to each other, or we've got aligned in the solution, so the two arrows will point in the same direction. In this case, Inventor's picked that one up automatically for me, so I don't have to worry about that. But if at any point I did want to switch that around, I've got the ability to switch that around, and you can see that those two arrows are now aligned. In this case, it was correct the first time around. So if I hit apply on there, with this being an insert, it's a cylindrical relationship. So this will then be able to rotate around in that. And now if I wanted to lock that one's rotation, obviously I could then just come in and apply that to another dial on the other side. So I'm just going to use this one on the opposite side, but it could be any one of those as long as you've got it configured correctly. And you don't have to apply a relationship between all of the parts. So you don't have to come in and apply a relationship to each of the dials. As long as your part is locked into the correct positioning, and you can't then toggle it to move it around, you should be good to go from there. It's more just to make sure that you've got everything aligned and assembled correctly. So if I just had to come in and struggling with this guy a little bit, you can see this one's now in the opposite direction, so I'm just going to leave that as is. I think I'm using the wrong geometry. Apologies for that. Struggling to pick that up because of the geometry I've modeled in. Let's there we go. That's better. You can see that's now automatically picked those up for me, so that's perfect. I'm just going to hit apply, and you can see this one's created a mate constraint between those. So you could use a mate, or you could use an insert. If I hit apply on there, if I now move this, it's not going to move around anymore. One way we can analyze this as well very quickly is if we go to the inspect, sorry, not the inspect, it is the always lose this one. Why am I losing this one? There we go. Under view, we've got degrees of freedom, and that'll essentially show any degrees of freedom that an individual component will have. And we can manage these relationships as well inside of the relationships panel or the relationships folder in the model browser over here. So if I expand this out, sorry, relationships, not representations, you can see all of the individual relationships that are inside there. So all of the constraints. If I had to, for example, remove this one over here by right clicking and deleting it, you can see that the degree of freedom, the amount of movement that's allowed, is only at that particular pivot point over there, and it's got a rotational degree of freedom, so it can rotate anywhere around that axis. And you'll be able to see if we have to remove any of the other ones. Just for the sake of this demonstration, I'm going to remove everything. You can see every single component now has the ability to move in any direction as well as rotate around any axes. So we've got the ability to analyze that using the degrees of freedom inside of the View tab. Awesome. The other way we can come in and add relationships between parts. So as you've seen, we've got the ability to lock between planes and axes, individual planes and axes using constraints. They've also added the ability to create joints, and this is a little bit more intuitive. It will basically pick up based on any of the geometry that you have inside of your parts, and be able to create a relationship between your two parts using any bit of geometry that exists inside of your components. So I've got here just this plate and a single bracket. I'm going to come in and drop in the rest of this assembly quickly. So I'm going to come in and place, and I believe it should just be in wheel assembly. So I'm going to place down a wheel, because obviously a wheel assembly needs a wheel. Place that down, hit escape, and go place down a plate. We've got the plate. We only need a bracket, an axle, and that should be it. So if I'm going to, I can come in and grab multiple at the same time and just select open, and it'll place those down for me. I can then again hit escape, and it'll then remove that from the selection there. So you can see in the relationships panel, we've got next to constraint, we've got the ability to create a joint. Now a joint, as I said, will look at the geometry of the component that you're wanting to create the joints between, and essentially create multiple points along the surface or along the geometry of that. So if we have a look at this face over here of this bracket, anywhere along the face, either at an edge or in the middle of the edge, so on a corner or the middle of the edge itself, we've got a point that we can choose from. And then some surfaces will also have right in the center of the surface. All cylinders will have 3 points that we can choose from, either the outside on the one side, the outside on the opposite side, or right in the center of the cylinder. If I hold down Shift, I can then switch between them. Control, I can switch between them as long as that particular one is selected. So as long as this one is highlighting in my browser or in my view, I can hold down Control and switch between the different points. And that just helps ensure that nothing else is then chosen during that selection process. I'm holding down Control and moving my cursor all the way off that face, and it's still giving me the ability to pick those points. If I had to come and look at the face over here, there's this top face over here, you can see there's a point right in the center. So any of the square faces or simple faces will have a point right in the center. Otherwise, it'll have different points along the sides that we can choose from. And you just want to make sure that the two reference points, so again, it's choosing a reference point on one body and a reference point on another body, and how those two relate to each other. So you just want to make sure that you're picking the correct places for each of those. So just a case of coming in, selecting that one there, right down the bottom middle corner of that bracket, and then choosing its opposite point to make sure that the alignment is correct as well. So just that point over there. And you can see that once come in, it's created that relationship, but now maybe those two are the wrong way around. We've got the ability to flip those around. So we've got the ability to flip the alignment. And we've got the ability to flip the connection as well. Sorry, I'm choosing the wrong button here. So let's try that again. We've got the first point, which is there, and our second point, which is there. That's perfect. And we've got our alignment, which we want to choose there. Let's just give that another selection. I've chosen the wrong button there. Apologies for that. Let's just try it again. So first selection, second selection, and we've got that there. If we want to flip the direction, we've got the little flip button to the side of that. We can flip its orientation or its alignment as well. So if we had to do that and that, you can see the complete opposite is what we were needing for that one, and it's adjusted that alignment. So having that one turned off or flipped in the other way, it changes the direction, and the other one changes the alignment. So just with a single selection now, instead of the multiple that would be required for constraint, we've now got the ability to come in and apply that joint between those two. And you can see if I drag this now, it doesn't move around anymore. We can also come in and again, using these joints, we've got further options. So by default, it'll pick up an automatic joint. So therefore Inventor knows what joint to use. Otherwise, we can drive exactly which joint we want. So if it's under automatic, Inventor will create a joint based on the geometry itself. If we want to override it, we can come into the drop down and say, you know what, we actually want a rigid joint, or we want a rotational, slider, cylinder, planar, or ball. Rigid will ensure that those two planes, similar to the mate constraint, except where those two planes are attached, there's no movement whatsoever, no rotation and no movement. Rotational will allow some rotation on that particular one. Slider will allow, very similar to the mate constraint, it just allows constraints in one direction, but it will then be able to slide around on there. Cylinder will then allow rotational movement, and they're quite well named as well, so that it's quite intuitive in the naming convention, so you could play around with those as well. So for this case, I want to create a relationship or a joint between the axle and the brackets themselves. So I'd want a cylindrical constraint there, or joint rather. And I want to then pick that between this face over here, maybe about the middle of that face, or that cylinder, and then the middle of this one here. And you can see by creating that, it's allowing movement back and forth as well as rotation from there. So if I hit apply on there, you can see we've got rotation available to us. I suppose you can't really see rotation that much on this one, but it has the ability to rotate around on there. And what we can then do as well on top of that is then just add another joint, this time between the wheel and the axle that we've just placed in, And instead of it just being an automatic one, I want it to be a rigid one because I don't want any movement between the two. I want all of the rotation to happen at the axle itself. So I'm just going to hit apply on there. And then we've got this wheel that's now able to rotate around in there. It's able to move back and forth, and that's just because of the rotational element to the rotation constraint or the rotation joint. If we wanted to, we could then lock the positioning. We could set an offset from the center of that axle to the side of the bracket itself, and just make sure that that stays in place. But now we've got a fully moving object available to us, which is great with the joints. So we've got the ability to ensure that those are able to move around, and that's essentially the ease of using joints. So it combines multiple constraints into one single joint between two bodies. So you only should need to use one joint between bodies. Sometimes you can add more, but generally speaking, you'd want to only use one joint between bodies. One of the other things I want to show you quickly is just under this Vice final assembly file over here. We've got the ability inside using our assemblies to kind of analyze and detect certain things inside of or during the movement or during the creation of our assemblies as well. So just having a quick look at this this vise that's been assembled for us here. It's fully constrained in the fact that it has all of its relationships built up. It's got all of its constraints. So you can see by rotating this around, it allows the spindle itself to move around, and it's also allowing us to move the spindle back and forth, and this entire moving jaw can then go all the way in. But obviously now what we're detecting is that there are some collisions that are available or possible rather as part of the setup. What we could do if we wanted to is we could create a constraint and drive it inside of Inventor. So we could come in and set this constraint over here between these two faces and ensure that they have some limitations to them. We can come in and say between this face over here of the fixed jaw and this face of the moving jaw, we want to set a offset of maybe 40 mil, and we can then apply that. Or if we expand our further options, we've got the ability to set limitations to that. So if we wanted to, we could come in and set a maximum, and we could also set a minimum of maybe, let's say 10 mil. And if we hit apply on there now, what that essentially will allow us to do is move that back and forth, but it'll only go up to a 10 mil offset, and it'll only go back to a 40 mil offset. So if you wanted some form of conditioning to the relationship itself, we've got the ability to add those limits in as well if we wanted to at any point. But say for example you're designing and you don't want to add in these limitations. I'm just going to come in and delete that new mate that I've just applied there. Just hit delete on there. But say for example you wanted to ensure that that two objects can't actually collide with each other. As you've seen, these two can just come in and collide. What we can do as well inside of Inventor is we can add what they call contact solvers. So by adding contact solvers, I'm just going to select these guys over here quickly. We can then make groups of objects that then won't be able to go through each other. They'll be considered solid geometry, and wherever they come into contact with each other, they obviously then stop right where they are. I was going to select all of them, but in actual fact we don't have to select all of them. We can just come in and say between the spindle, this moving jaw, maybe this base one, and the fixed jaw itself, we want to just make them contact sets. So if we right click on any one of those with those selected, we can turn on contact set, and what you'll notice is we've got this little icon that appears next to the item inside of the browser, and that just ensures or gives a visual feedback that these are now part of a contact set. If I go over to my inspect tab, I've got the ability under the interference panel to turn on contact solver, or I could turn that off and contact solver will then not be active. So by default, even with those contact sets turned on, it doesn't necessarily mean that's on yet. We would need to turn activate contact solver. And as soon as we've done that, you can see now, as soon as those bits of geometry come into contact with any other, you can see I'm just bringing that to that point there. And because it's making contact over here, it's not allowing me to move that any further. The same will be the case the other way around. So if it does a bit of a jump there, but you can see if I'm moving this over here, it's not moving past that point. So wherever it comes into contact with a contact solving body, with another contact solving body, it won't be able to move beyond that point. So that's all good and well, but maybe sometimes you wanted to sort of see how much of the part will go through a particular item or another part, how much of the two parts will essentially will come into contact with each other, or how deep another part would go through another part. Maybe you want to allow movement. In this case, as you can see, it's only going to go up to that point there, but we want those two moving jaws to go a bit further. We could, by all means, extend the length of the spindle itself, but maybe we want to just make sure that there's a bit of a gap in here where we can come in and cut out and allow the head of the spindle itself to go in. What we can do then, if we wanted to, I'm just going to turn contact solver off quickly and just make sure that this is then aligned all the way to there. In this case, obviously, we're going to have, we would obviously have another jaw or a pad just for protection over here on the moving jaw itself. So it won't be all the way up to that, but just as a form of reference, what we can do is we can actually solve how much volume is being intersected, essentially. So we've got the ability to come into our analyze interference option inside of the interference section over here, and essentially, if I turn this off here quickly, there we go. It allows us to define two different sets of bodies to two different sets of geometry or parts, and compare the overlap between those. So there might be some that you are happy with, some of them obviously that you don't want. So we can come in and choose a set 1 and a set 2, and as soon as we hit OK on there, you can see it gives us a bit of a preview as to how much of that volume is being considered to be intercepted or interference, essentially. So how much of that is intersecting another part. You can see we've got a total of 2 interferences and with a total volume. So we've got some over there, and we probably would have some on the other side as well if I'd selected that spindle. But it's essentially picking up between the main body, the fixed jaw, and the moving jaw, essentially. We could then use that data to analyze how much volume we need to take out, or where these intersection points are. And you'd imagine this is the same for bolts. If you have bolts going into a part and they need to be cut down a bit, or you need maybe shorter bolts, you've got the ability to very quickly analyze that using our analyze interference option. So yeah, I hope that's been beneficial for you. Sorry, I've gone over a little bit, but yeah, just wanted to drive home the fact that we've got the ability to come in and create our assemblies using constraints, using joints. And then on top of that, we've got the ability to drive those joints as well, or drive those constraints as well if we need to. So we've got the ability to add some limitations to those. And then we've also got the ability to analyze the movement of those inside of the assembly environment. But yeah, thank you so much for your time. That's all we're going to go over today. Please feel free to obviously watch all of the other videos that we've made. This is the second one in our series, but we'll be making many more over the next few weeks and months. So yeah, feel free to have a look on the rest of our YouTube channel. But until next time, thank you very much. Goodbye.